VS Series, Edge Position Tool. The Edge Position tool detects and counts edges in the X, Y, or angular direction in the inspection region and outputs the positions. The edge detection is based on the amount of intensity change and not an absolute value of intensity. Connect to the Edge Position Tool simulator and play through the images. These test images will be used to explain the edge detection settings in the Edge Position tool. The goal is to detect these edge transitions here. Add the Edge Position tool to the inspection section of the main task. It is available in several categories. For this example, we will add it from the Count category. Start with image number 1 in the film strip and draw the inspection region as shown. Scan direction is the direction to which it will scan for edges. As a default, it's set for forward when you have a rotated rectangle. And forward is the direction of this arrow here. So if we zoom way in, you'll see this small blue arrow on that rotated rectangle region. So forward is meaning it scans in the direction of that arrow. You can also set it for reverse, which will be reverse direction of the arrow to scan for edges. So you can rotate this rectangle as needed, depending on the target condition and what edges you're looking for. The way the edge tools work is they take the average intensity down each pixel column in the direction of scan. In this case, left to right. And then it plots the differential, so where it sees the differences. In this image, you can see it's very noisy, so we're getting a lot of noisy edges here. So one setting that can help clean up noise on the image is called the edge filter width. It applies a smoothing filter to the graph. So if we set this to 30 in this example, you can see it smooths out that noise and we're getting the edge transitions that we're looking for. Edge direction will specify which direction of edge to look for. An edge is either a bright to dark change or a dark to bright change. As a default, it's set to look for both, but you can dictate or determine which edges you want. So if you set it to bright to dark, it will only look for bright to dark changes. Or if you set it to dark to bright, it will only look for dark to bright changes. For this example, we will leave it on both, but set that according to the application. When viewing the edge graph, the graph will show areas where it's detecting a differential, where the differences are occurring. Whatever the biggest difference in intensity that it finds in the region, that gets displayed in the upper left corner of the graph here. So in this example here, 36.4 is the biggest change of contrast it found. And what the edge algorithm does is it normalizes that to 100%. So the biggest edge that it finds becomes normalized to 100%, and then all the other edges are plotting based on that. The edge sensitivity will dictate what edges will be detected. It's given as a percentage. Again, the biggest edge that it finds becomes 100%, and all the edges are plotted accordingly. So sensitivity will dictate which edges are actually detected. So as a default, it's set for 30, which is indicated by this yellow line. When you are editing the edge sensitivity percentage, you can see the graph displays the 100% in the upper left here, and all the edges are displayed here. So you can adjust this according to the situation. So if we raise this up to 50, for example, you can see the yellow line is raised, and it will ignore any spikes or edges that are below this line. So you can adjust that as needed. For this example, we'll just leave it at 50. The edge intensity upper and lower limit can be used to filter out unwanted edges. The lower limit as a default is set to 5, which is indicated by this green line on the graph. If we raise this to 15, for example, any edge with a strength or change of intensity less than 15 will be ignored. You can also set the upper limit. Generally, the upper limit is not adjusted, but if we wanted to get rid of stronger edges and make lower intensity edges stand out, we could adjust the upper limit setting as well. So in this example, you can see the strongest edge we have right now is 36, about 36. So if we set an upper limit of, let's say, 35, it would cut off any edges that are stronger than 35 and only report back edges that are less than that. So you can see it ignored those larger edges. So we're going to put this back to 255, and we'll leave the lower limit at 10 for this example. So basically, for an edge to be detected, it needs to spike or be stronger than the lower limit and the edge sensitivity setting, and not be eliminated by the upper limit. So the graph will show the edges that are being detected, and you can proceed with all the other settings. In the options settings, you can set the maximum edge count. As you can see right now, it's set for 30. So if I change this to 1, for example, it will only count one edge and ignore the rest. So this is the maximum number of edges to count. And the judge label can be set here. You can see the edges are numbered in the direction of the scan, starting at 0. So 0, 1, 2, and 3, as you can see here. And as a default, the judge label, which is the primary target, the one in green, is edge 0. But that can also be changed as needed. In the tool results, you will see the results of the number of detected edges, or the count, in this case 4, and then the position of the judged label. In label results, you can also get the positions of all the other edges displayed here. But under the tool results, the judged label is the one being displayed. Once you have the desired edges being detected, you can set your judgment limits under the judgment settings here. So you can set a limit on the count. As you can see here, we'll go ahead and set an upper and lower limit of 4. So we can fail this if there is not 4 edges. So if you play on image 2, you'll see there's only 3 edges detected. So it will fail based on count. You can also fail it based on the position. In this case, we are going left to right, so the X position is the one that varies. The Y position in this case, for reference, is basically the middle of the inspection region, so that's not going to change in this example. We're only working with the X. So if we put an upper limit in this example of, let's say, 270, because our current value is 264 about on the good image, which is image number 1. And we can put a lower limit of, let's say, 260. So we can also fail it if the judge label, in this case, edge 0, gets out of position. So you can set your limits according to the application and pass and fail the tool as desired.